Hello, class. Just left you with the 2.3 video. Now we're going to get into 2.4. So the main difference between 2.3 and 2.4 is now all our problems are going to have three sets. Right? So there's going to be three circles in our Venn diagram, which means they're a little bit more complicated. But it's the same basic idea. And it makes it a little bit more interesting when we like create the Venn diagrams. We're going to give you sets and you're going to create the Venn diagrams. But then once we do that, then we're going to, go back and do all our set operations and all that sort of stuff as well. All right. So in Blackboard, so if you go to the resources, so the 2.4 and 2.5 notes are kind of in one document. That's just how I had them saved. So this 2.5 again is an extension of 2.4 and 2.3. It's more just putting it in word problem format. And so that's why they're the same document. All right, so let's get into the problems. Kind of nice that we're not doing new material here. It makes it a little bit easier to get set up and get back into document camera. Okay, so 2.4, three set Venn diagrams. All right, so we are going to talk, just like we did with the two set Venn diagram, we're talking about the regions. But before we do that, let's play around with them a bit. So number one is a basic problem. We're going to construct a Venn diagram using the following sets. So the universal set is 2, 4, 6, 8, 10, 12. A is 2, 6, 10. B is 2, 4, 8. And C is 2, 8, 10, 12. So what we're going to do is we're going to take all these elements and put them in the appropriate regions in the Venn diagram. So the question is, where do you start? Okay, so anytime that you're creating a Venn diagram, here's my tip. You start on the inside and work outwards. Sort of like if you have a word of operation problem, you start with the parentheses, inside the brackets, and work your way out. You're going to start inside and work outside or work outward. All right. So what do I mean by start on the inside? Well, if you look at our sets, A, B, and C, what do they, should kind of jump out at you that they all have two. Well, where is that two going to go? Where is NA, NB, and NC on this Venn diagram? Well, right there in the very middle. Because that region is in circle A, that region is in circle B, this region is in circle C. So that very inside is all three. So 2 is the only number that's in all three. So 2 goes there. Now cross that off because we've taken care of it. So especially make sure you cross it off in the universe. All right. So that's the quick one to do, is the one that's in all three. All right. Now what I do is let's start with A. So we have 6 and 10. Okay. So what is A? Well, A is this entire circle. Okay. So there are 4 regions in circle A, or set A. All right. So where do we put that 6 and the 10? If we just put them out here, well, what do we say about those regions in the 2-set Venn diagram? Those are the ones that are only in A. But are 6 and 10 only in A? Well, if you look at 6, 6 is not in B, 6 is not in C. So yes, 6 is only in A. So that 6 is going to go out there. Okay. So take care of 6. But now if you look at 10, 10 is in A and it's in C, but notice it's not in B. So where does something go if it's in A and C, but not B? So it has to be in the circle A, has to be in the circle B, or sorry, circle C, but not B. So here's where those quarters come in. 10 is not in B. So where can it go? To be in A and C, and then overlap right here. So notice that, that 2 is in A and C. It just happens to be in B as well. The 10 is not in B, so we can't put it in that circle. So now we take care of 10. So now A, we've placed all three. We placed the 2, 6, and the 10. Now for B, we haven't placed the 4 and the 8. Okay. Well, for the 4, is it in any other set? No. So since the 4 is not in any other set, it's only in B. And where's the region that's only in B? Well, of those 4 regions, where is only B? Well, can't be in A, can't be in C, but right there is only in B. Okay. Now what about the 8? Well, the 8 is in B and C, but if you notice, it's not in A. So if it can't be in A, quarters fit really nicely in those circles. Sorry, that makes me smile. All right, so if 8 is not in A, but it's in B and C, it has to be in the overlap. But 8 has to go right there. All right, so are we done? Well, that's why I'm crossing them out as we go. So A and B is done. Now for C, we haven't placed 12. 12 is only in C. So it can't be in B, can't be in A. That means 12 has to go here. Now, are we done? You have to be careful because sometimes there are things that are in nothing. If you notice, it's been crossing them out. We've used all the elements in the universe. So there is nothing that's only in the universe. And if you notice, there's also nothing up here. What does that mean? That means something that was in A or B, but not C. There was nothing that was just in A and B. Okay. So that's a good warm up. I'd like to see if there's any questions on that, but I can't. So we're going to just have to jump to the next one. All right. So this one has more elements, so it'll make it a little bit more interesting. All right. So again, and if you have colors, that might help. Okay. So there's A, purple, pink will be blue, B for the pink, and then orange will be C. All right. So if I want to place these elements in here, where do we start? And again, always try to start with what's in all three. So A, nope. E, nope. I, nope. O. So there's nothing in A that's in B. So there's nothing in all three. So that means there's nothing in the center of this one. Okay. Now, once you take care of the center, if we're talking about number of elements, then we would definitely go to these 3 parts, but that's more like 2.5. So so now let's just once I do the very center for everything, then I just start placing the elements in A. Okay, so for A, we have the little a, and so if you notice little a, it's an A and C, but not B. So it's not in B, it's an A and C. So little a goes there. E, well, E is also in C, but not B. So E goes there. And then I and O are in nothing else. They're only in A. And so where is the only in A? Well, not in B, not in C. So I and O go out there only in A. All right, so now let's do the same thing with B. All right, so the set B, So look, letter B is in B and C. It's not in A. So we don't want A, we want B and C. So there's little b. Little c is also in both, but not A. So little c would go there. D is the same way. F also, that's a crowded little region. And G, that's a very popular. All right, I'm gonna have to draw an arrow. Okay. So G, so there's B, C, D, F, and G are all in B and C, but not A. All right, so now what about H? So H, J, K, L, M, those are in nothing else. So those are only in B because they're not in A or C. So H, J, K, L, M. So H, K, L, M, N. All right, so it takes care of B. What about C? Well, for C, we've already placed A, we've already placed B, C, D, placed E, F, G. So everything that's in C has already been placed. So we're done with C. So there's nothing that's just in C. All right, are we done? Well, this is why you cross stuff out in the universal set. So P has not been placed yet. So P has to go outside the circles somewhere in the universe that's not in one of the three sets. All right. So hopefully I didn't go through that too fast. If I did, apologize. But really, start with the very center, see if there's something in all three. And then, like I said, if you're placing elements, then I usually just start with my shortest set and then figure out, one, make sure you know which circle you're talking about. And then is it in the overlap with another circle or is it just in that element? Or sorry, just in that set? Once we start talking about numbers, then we're still going to start in the center, but then we'll do the intersections and kind of work our way out for sure. All right. So that is one type of problem, is where we can just give you sets and say where at in the Venn diagram do they go. All right. So how about number 3? Consider the following chart, which teams show that I've won at least 6 medals in wine tasting competitions. I'm guessing this is what, California or maybe Maine, I don't know, or France, who knows. Let the vineyards represent the universal set. So all of these vineyards together make up our universal set. So that means all of them are going somewhere inside our box. Okay, so A is going to be the teams that won at least 33 medals. So that tells us A are those two because they won at least 33. And now notice it says at least 33, so that at least does include the 33. B is the set of teams that won at least 8 gold medals. So for 8 gold medals, let's use purple for them. Franklin and Upper are so A. Purple is at least 8 gold. So that is everybody but Parkway and Greenville. And let C be the set of teams who won at least 5 silver medals. And so let's do pink. This. So for 5, at least 5. So at least 5 silver medals. So those aren't in order like the gold are. So again, that'll be everybody but Springton and Greenville. Okay. C is pink, B purple, and A. Okay. Now, what is missing in this problem? The actual instructions. And so what it doesn't say here, yeah, is we need to put these in the Venn diagram. And then each one of these has so each one of them has a unique initial. So we'll put that. So is there anybody in all three? Is there anybody that had at least 33 metals, 8 gold, and 5 silver? Well, we know there's only 2 elements in A, or 2 vineyards in A. So basically, is Franklin or upper? Those are 2 in A. Are they in any other sets? So if you notice, Franklin is in all 3. So Franklin goes in the middle and is upper in the middle as well. So both Franklin and upper are in all 3. So Franklin and upper. So a U and an F in the center. All right. So that takes care of A. So A is done. Because there's only 2 elements in that set. So let's go to B. So B has 5 vineyards. All right. So we've taken care of Franklin and upper. So there's only 4. So now we need Springton and Inland. So are those in any other sets? Well, Springton, if you notice, is only in the purple set. So that means they only want 8 gold. So Springton is only in B. That's up here. Now Inland is gold and silver. So that's pink and purple. And so that would be right here. It's not in the green because they didn't win at least 33 medals. All right. So how about silver medals? Well, we've already taken care of Franklin, Upper, and Inland. We haven't taken care of Parkway. Parkway is just in the silver. Put a P for Parkway there. Now, are we done? Well, Greenville didn't get listed in any of them. So there have been vineyard owners from Greenland. They need to Greenville. They need to get some work done, but they're going to be on the outside looking in of our 3 cents. Okay. So that's a bit messy. That's a word problem version of what we did before. Okay. So if you're still a little iffy on that, well, now let's talk about. Oh, it's kind of bleeding through. Sorry. So let's talk about our regions. All right, so just like with the 2 set Venn diagrams, we label our regions. And so let's go through, describe each one of those. We're going to do a 3 set Venn diagram. And again, we're using Roman numerals. Right. And now when you're doing your 3 set Venn diagram, you'll make it a little bit bigger so that you have room for that 3rd circle. You tend to go start with A and then go clockwise. All right, and so when we name or number the regions, it's the same as here on number 4. So we start with 1 in the only A, and then we go basically across. So this would be region 1, region 2, region 3, and then we drop down here to region 4, 5 is in the very middle, 6 is right there, 7 is here, and then 8 be anywhere outside those 3. So 1, 2, 3, 4, 5, 6, 7, 8. All right, so what do those regions mean? So for region 1, again, please don't tell me region 1 is A, because A is 4 regions altogether. It's 1, 2, 4, and 5. If I'm region 1, what can you tell me about that? Well, they're in A, and they're not in B and C. Region 1 is A only. What about region 2? Well, region 2 is in the A circle. It's in the B circle. but it's not in the C circle. So this is A and B, but not C. What about region 3? Well, it's in B, but it's not in A, it's not in C, so it is B only. Okay. How about region 4? Region 4 is right here. So I know it's in A, I know it's in C, but it's not in B. It's A and C, but not B. All right, so this is where you kind of, if I didn't cover that at the quarter, if we're talking about that region, you have to see that it's in that circle, it's in that circle, but we're kind of ignoring, the B circle because it's not in the B circle. All right. The region 5. Region 5 is right there in the middle. That's in all three. That is in A and B and C, which I want to point out that if we do A and B and C, that's the same as A intersection B intersection C. Okay. Now, and this would be like, we don't normally put the rest of these, but if I want A and B but not C, that would be A intersection B and C not. That would be how we do that. We don't normally do a lot of that. It's more just the intersection of all three that we do. Okay, so what about region 6? Region 6 is right here. The region 6 is in the B circle. It's in the C circle, but it's not in the A circle. So region 6 would be B and C, but not. Okay, so now what about region 7? So region 7 is definitely in C, but it's not in A, not in B, so it's only in C. Okay, so these regions here are the ones that are the onlys. And so this is only A, only B, only C. Then if they're in the outer intersections, that means they're in 2, but not the third. So this one's A and B, not C. This one is A and C, not B. This one's B and C, not A. What is region 8? Yes, it's part of the universe, but they're all in the universe. So this is the elements that are in the universe that are not in A or B or C. In the universe. And not A or B or C. So if I wanted to do notation for that, the ors would be A or union B, union C, and then we don't want that. So if you're getting to the point where that's starting to feel a little bit more comfortable, you're definitely in good shape. If not, then that's why you're practicing. Okay. All right, so let's see. All right. And again, I'm sorry for the bleed through. I didn't realize that was going to bleed through like that, but we'll get through it. So there's our consonants, that our B's are capital letters, our C is our vowels. It wants to know what region capital A would be. So capital A, it's not a consonant. It is a capital letter, so it's in either region 3 or 6. Okay, it is a vowel, so it has to be in C as well. So what's the only one that's both capital letters and vowels? It would be region 6. Now, lowercase a, but still not a consonant, so we're still crossing that out. It's not a capital letter, but it is a vowel, so it has to be region 7. Again, what helps, can't put your, you can't put computers up on your calculator. So you can't put quarters up on your computer screen, but if you have it on paper, it's kind of nice. All right. So let's do the next one. C, little lowercase c is in what region? Well, lowercase c is not a capital letter. It is not a vowel. That's region 1. Okay, where is 4? Well, 4 is not a consonant, not a capital letter, not a vowel. We're running out of quarters. So that means it's outside all the circles. So it'll be region 8. All right. So that's one thing that we can do with that is just, again, this is practice reading your Venn diagrams. What goes where? Now we need to be able to do operations with them. Okay. So, actually, I'm going to pause this right quick and I'm going to print this out again. So I'll be right back. All right, sorry about that. So I had to clean out a clean copy so that we could actually read without the bleed through from the previous page. All right, so use the Venn diagram to show the list, to list the set in roster form. All right, so here we have our Venn diagram. It wants to know what is B. So where is B on this Venn diagram? Okay. And again, please don't tell me it's just 7 and 14, because those are only in B. So B is the entire circle. And so B is the set, switch curly brackets. So 11, 4, 12, 7, and 14. Oh, and by the way, this is where sometimes I see MATLAB say, like, list them in ascending order. So if that was the case, then, they would, you'd have to do 4, 7, 11, 12, 14. So just watch the instructions in MATLAB. This is where, if this was a test and the MATLAB said put them in ascending order and you put them in just, as long as you got all the elements, that's what I'm really worried about. All right, so that is B, that's that circle. Okay. So what is the universe? All right, and again, please don't tell me it's just 5 or 1, because those are in the universe, but those are not the only ones in the universe. So the universe, remember, is the entire box. I'm not going to list them all out, but it's 1, 5, 3, 3, 6, 9, 13, 11, 2, 8, 10, 4, 12, 7, 14. So it looks like everything from 1 to 14. Okay. So universe is everything, not just the stuff that's not in the sets or the subsets. Okay. So what about a intersection C? Okay, so intersection is what they have in common. So what do these have in common for A and C? That is the intersection right here. I'll circle it in orange. All right, so that means that is 11 and 13. Probably should have printed out more than one copy of this. Okay, so now B union C. So now we're doing union. Remember, union is everything in the sets. So B union C, it's everything in B, and as well as everything in C. So B union C is like all of those circles. Good, good. So it's not the stuff that's just an A or B. It's not the stuff outside B or C. So there's our B union C. All right, and again, if MATLAB wanted these in order, I'd worry about it. But here I would say it's 2, 8, 10, 13, 11, 4, 12, and then 7 and 14. So B union C is everything in both of those circles, or in either of those circles. I want to avoid using both because then both tends to sound more like intersection. Okay, how about C complement? So again, since this is on paper, this comes in really handy. C complements everything in the universe that's not in C. So I'm not going to write this one out, but here you go. It's 1 and 5, 3, 6, and 9, 7, and 14. So complement works just the same with 3-set Venn diagrams for a single set like it does with a 2-set Venn diagram. All right. So how about the 2 operation? So A intersection complement of that. So where do we start? All right, well, we start inside the parentheses. So start with A intersection B. So come up here, where is A intersection B? Well, my Venn diagrams are a little messy, but remember, intersection is where they overlap. So A intersection B is right there. So it's both of those. I don't care if 11 is in C because we're not talking about C right now, so just pretend that circle isn't there. All I care about is the overlap between A and B. So 11 is one of those things in the overlap. So now we want the complement. So how do you find the complement? Well, the complement is everything in the universe except what's in our set. So the complement of A intersection B is everything except 11. So it's the entire box but 11. So I'm gonna get a little lazy on writing this out, but this is everything except 11. If I could roll out all the numbers by now. That's 1 through 14, but you get the idea. All right. Sorry, it's time for lunch, so I'm getting a little antsy here. All right, but that's how you do a two-step on a two-step operations on a 3-set Venn diagram. Still, figure out what's first, get that set, and then do the second operation. And again, this is showing your work. On a test, get that first step. If you get that first step wrong and don't show your work, often I have very little idea if you did the second step right or not. Okay. But this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14. All right. And we could get messier, but I think I kind of backed off on that. Like a lot of the messier operations I saved for 2.3 with the 2-set Venn diagrams. Okay, what else do we have here? Now, there's not so much shading it in the homework. I'll bring this up after I do these. But just again, some of these are pretty basic. So if I want to shade A intersection C intersection B, where is that on the Venn diagram? So intersection is what they have in common. So if I want to intersect all three, that is just the middle. So the intersection is of 3 is the inner side. Like I said, the triangle parts are intersections of 2 sets, but not the third. Okay, what about the union? My circles are getting kind of off. Like I said, it's time for me to go eat lunch. All right, so what is union? Union is all the elements in the first set as well as all the elements in the second set. Now that we have a third set, it's all the elements in the third set. So it's everything in A. It's everything in B. It's everything in C. So yes, some regions got shaded more than once, but I don't care. All I care about is getting, it's all the elements in A, all elements in B, all elements in C. All right, now 14 and 15, those are kind of sort of advanced, but let's relatively short video, so let's play around with more room on 15. Let's see if we can do one of these. Like I said, this is advanced topics here. Okay. All right, so we're doing A union C intersection B complement. All right, so where do we start there? We have a union, have an intersection, and we have a complement. Well, by order of operations, complement works like exponents. There is no parentheses here, so you do exponents first. So we don't want, so B complement is all of that. It's everything outside B. Okay. And then how do you do the other two? We kind of go left to right. So if you do A union C, so A union C would be like all those, but we don't want, or we're intersecting that with B complement. So like I said, this is getting messy. So A union C, here's where sometimes I'll do two different colors. So there's A union C. Here is B complement. Okay, and so we want the intersection of those two. So the intersection is where I shaded both. So where did I shade both? So this is where I want horizontal and vertical. There's horizontal, vertical. There's horizontal, vertical. That's A or C and not B. So I don't want anything in B. If that kind of makes sense, then that's fantastic. If it doesn't make sense, then the real question is, are these making sense? Okay. Because like I said, these are kind of like, I kind of expect you to know by the time you're done where the intersection of all three is and where the union of all three is. Beyond that, we'd have to spend, definitely, this would be a deep dive into what we're doing. All right, and then 16, 17, those are 2.5 problems. Those are survey problems. So this is where we get like, you kind of see there's like, we basically figure out what's A, what's B, all that sort of stuff. That will be next video. Let me jump into the homework. See if there's anything else from 2.4 we need to discuss. All right, let me here. Now, I was just randomly picking one, and so I jumped to number 14. This is one of the messy ones because if you notice, it is A union B, union C, complement. Well, actually, that comes out to, that's really nice. We did the union of all three. So the union of all three was all of the sets. So it's everything in A, everything in B, everything in C. The complement is none of that. So we don't want anything inside the circles. So that means that's 19. Because we do inside the circles first, that's the parentheses, and then we toss it all out, and what's left over is the 19. Construct a Venn diagram. Notice that this is multiple choice. How many choices? They'll only give us 3 choices. All right, this might, okay. So we have 3 sets plus the universe. All right, so I don't know about you, but in this multiple choice, so let's start on the inside. So if you notice, B has 17 on the inside in the very middle. A and C have nothing, so we can narrow it down there. So where is 17? 17 is in A. 17 is in B. 17 is in C. So this is, to me, a very poorly worded multiple choice. since 17 is in all three, it has to be in the middle, and 17B is the only one that has 17 in all three. That like I said, that's a poorly worded multiple choice problem. But I figured it out just by starting with the inside. All right. Okay, so 16, that's kind of a jump back to what we were doing in 2.3 without the Venn diagrams. And so this is where, oh, this is kind of the same problem as 15 without the Venn diagram. So we do A union B union C first. So how do you do union of three sets? The same way you do union of two sets. You list everything in the first set, then you list everything in the second set you haven't listed, then you list everything in the third set that you haven't listed. So let me do this one on paper. Okay, so this is number 16 in the homework. 2.4 homework. All right, so what they want us to find is A union B union C complement, where A is EFH, B is AFH, and C is ABC, D, B, C, D, and then G. All right, so step one, do inside the parentheses. We're going to do A union B union C. So how do we do the union of three sets? List everything in the first one. So we're going to do EFH. Go to the second one, list everything in the second that's not already been listed. So we haven't listed A yet. F and H are already there, so we don't need to add those again. Go to your third set, list anything that hasn't been listed. A's already there. I don't have B. I don't have C. I don't have D. And I don't have G. So remember, union is everything in each set. So it's all those, it's all those, and it's all those. Okay, so that's step one. Step two, let's go back to the universe and do the complement. Okay. So we're doing A union B union C complement. So we need the universe. The universe is A through H. C, D, E, F, G, H. Okay, so how do we get the complement? Well, we're taking the complement of this set. So we go to the universe and cross each one of those out. So we don't want E, don't want F, don't want H, don't want A, don't want B, don't want C, don't want D, don't want G. So we crossed out everything. So what does that mean our complement is? Well, hopefully you remembered. We haven't talked about it in this video, but when you're in this chapter and your answer is no answer or no set, that's the empty set. Or so you can either use the zero with the slash through it or the empty brackets. If there are no elements left over, that means empty set. Which in a lot of these, you have the A put in your answer, and then B is the empty set. Okay, so that's how, the first part of 2.4 has everything with the Venn diagrams. The end of 2.4 has no Venn diagrams, but it's still three sets. So it's the same basic idea that you've been doing before. All right, let me just do a couple more random ones just to in the homework, just to show you that it's what it looks like. So here is my number 12. So gives us the Venn diagram and wants A, intersection B, intersection C. So where is that? Well, again, that shouldn't come in handy because the intersection of all three is the very middle. The only thing in the very middle is 2. So here's like the regions questions. And so this is where you have to be careful reading the problem. It's real easy to overlook that apostrophe. Okay? But you got to look for apostrophes because those are our complements. So list the regions that represent C complement or not C. So we don't want C. So we don't want 4, 5, 6, or 7. So what regions are left? 1, 2, 3, and 8. Again, this is where if it was flat on the table, that quarter would cover all those up. You can often I use my thumb as well. That works. Um, how about this? A intersection C. So what regions represent that? So the intersection is where A and C overlap. So where do A and C overlap? We're not talking about B, so kind of pretend that circle's not there. All we care about is A and C. So A and C overlap right here. So it would be region 4 and region 5. All right, so that is sort of what you'll be doing with 2.4. Okay. Like I said, there's no new concepts in 2.4 compared to 2.3. It's just now everything is in 3 sets. So they're just like more regions, to keep track of as you're doing it. All right. So, and I'm gonna go ahead and do a separate video for 2.5. 2.5, we're going to be using the same ideas, but the reason it's called survey questions, this could be like survey, we're going to be asking people questions and using the results. And the sort of the new thing with 2.5, instead of listing the elements, we're going to talk about the number of elements. So we're still going to be going through the same ideas, the same regions and all that. It's just we don't care about individual elements. We care about how many there are. All right. So, but that'll be another video. So that's all I have for today. Have a good one.